Excellent, and we're back. We're back live. Oh, goodness gracious. You know, it's crazy to think that, like, I had you guys on Friday, and then we were, well, I'm going to put this in quotes, but we were snowed out for 2 days. Just like, come on, we weren't snowed out. And I got to teach from home. That was great. Was this the class where my daughter popped in the stream? I don't know. I can't remember because I did so many streams on like Monday and Tuesday. Whatever. All right. Huh? If my daughter popped in the stream. Oh yeah. You sure? Yeah. All right. Are you guys that didn't say a word and were like didn't even comment on how cute she was, and then I hated you guys forever? Does that ring a bell? No? I hate you all forever. Anyway. So if you would, those people in the live stream, some people have already started to leave their comments. Just says there was only 2 people there. That's weird. Anyway, we'll figure this thing out. Oh, someone's in trouble. Who's it going to be? It's Margaret's room. Yeah? Okay. All right, bye-bye. Giovanni. At the end of class, if you have an opportunity, they just want you to stop by guidance. Yeah. All right. There are some people leaving me some comments in the chat. Excellent. Joe in the chat is admitting that he was asleep last class and he missed my live stream from my room. So, Anyway, here's what I want to do to start off. For those people that are joining the live stream, getting in here, I want to do a quizzes first thing. I want to get a little practice. This practice is not going to count against you, although I will have something that will count as a grade soon. This particular quizzes is not. So if you would, people in the class on the Chromebooks, you need to get them Chromebooks out and logged on. That would be fantastic. For those of you that are in the live stream, oh, he says no for last period. For those of you in the live stream, obviously you're going to be going to quizzes. Joinmyquiz.com, and I'm going to have the code up for you in a few moments. But I'm giving people in the class a chance to kind of get logged on. Question? You have any charger. Okay. I don't know. Well, just since you guys have like similar Chromebooks, does anybody have a charger that he could just use for the class period? Since I'm assuming some of you might be a little bit more charged than others. There we go. Okay. Anyway, let me get this thing set up. And then people can begin logging in. Boom. It's going to be a short one. But I'm going to tell you what my intention and my hope is for these problems. Yeah, that's good. Boom. For those in the live stream, of course, I will type the code into the chat. Let's see, 410707. There is the code that I just put into the chat. Now, before we actually get this thing started, I'm going to tell you what my intention and hope is for these problems. But I just want to give people an opportunity to obviously get logged in as quickly as possible. That would be fantastic, as I see people are beginning to pop up in the lobby of this game. And again, for those of you in the chat, I know the glare is there, but it is 410707 as I've typed into the chat right there. Go to joinmyquiz.com and you guys can begin getting into that thing. That would be fantastic. Let's see here. Boom. let's see, 1, 2, 3, 4, 6. I got 6 in here, and supposedly I got like 9 in the chat or something. So people got to be joining that thing. So while people are joining that thing, let me tell you what my intention is. There are only 10 questions for this particular quizzes. 10 questions. Hopefully you do know that with a quizzes, even if the timer runs out, you can still get points on the leaderboard for that question. If the timer runs out, you still have the opportunity to answer said question. I want you to be deliberate with some of these questions. Some of these questions you can answer in like 10 seconds or less. Yes. Some of these questions, it is in your best interest to take your time, scratch it out on paper. So what I'm going to ask you guys to do, and especially I can't see you guys at home, but for you guys that are here, I'm going to suggest that you have scratch paper that you use to help you get this thing done. Mr. Marcus' room. No, she's actually in the live stream right now. I got you. Yeah, she checked into my live stream though, so we're good. Yes. Okay, gotcha. All right, bye-bye. Cool. So yeah, have that scratch paper ready to go. I got people in here. I got people out there. Now, again, I don't know if everyone has joined just yet. I'm going to take a quick peek around when I meander this classroom, but have that scratch paper ready for those of you at home. I would like to review some of these questions when we are done, and I would like to build upon the information that we have been teaching the last several class periods. So, even if I click start, you still have the opportunity to join. Please do that. Please take your time. There are only 10 questions. Here we go. One thing I definitely want to make mention to all you guys real quick, one thing I failed to mention before I started this thing, the radical symbol has a little bit of a formatting error. Assume that the radical symbol extends all the way across the terms. Assume that the radical symbol extends all the way. There's a little bit of formatting error. For you guys that are still in the middle of finishing it, because I think I have a couple people, I'm going to click to end it soon, probably in the next minute. And when I do, because I know you guys in the class right here, you guys are done. We're done with the Chromebooks for the time being. But what I will need from y'all, you can close the Chromebooks and you can have those notebooks out and open. There we go. Being that there were only 10 questions, I'm very happy with the time that you guys took with a lot of these questions. As I said, a lot of them you could get done in like 10 seconds or less. Some of them you did need to dig a little bit with. And I would like to go through specifically some of the questions that are labeled either red or yellow. And those specific questions I want to put into our notebooks. So as I said, for those of you in the live chat, if you don't already have them out, I'm gonna need those notebooks out and open. But of course, let's just see what kind of questions we were faced with. So, questions, none in the red, plenty in the green, but definitely some in the yellow. And those yellow questions I would like to go over with you. So let's see. What I'm going to do in my notes, I am going to title this, well, today is the 4th, and let's call this Quizzes Review Radicals. I'm going to have this as a part of my notes, and I am going to be building upon the information that we've covered so far today, but let's just see where this kind of takes us. The first question, which was actually number 3, was the third root of 64 m cubed. Hopefully you can see that right there. That is number 3. It's a little easier to see on my notes. We'll get this marker out of here. This marker is dead to me. That was a good one. Now, 64, I know that 64 is a perfect square, but this is not a square root. This is a cubed root. Being that 64 is a perfect square may or may not help me. Yeah, it's 8 times 8. But knowing something a bit more in depth about 64, knowing that it is also a perfect cube can be helpful. One way of handling this problem, one way of potentially going about this problem, would be breaking down 64 as far as it can possibly go. So I could look at 64 and be like, okay, divide by 2, 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 divide by 2. And you can do that 6 times. You can do that 6 times, absolutely. Now, I don't really feel like breaking down this 64 by writing out 2 times 2 times 2. I don't feel like doing that. Take a little bit of a shortcut here. The fact that 4 cubed is 64. Sometimes you can recognize stuff like that. Sometimes it can be helpful. Recognizing that 4 by itself, or 4 cubed by itself, is 64. So what I'm going to do for this problem is I'm going to break it up. The cube root of 4 cubed, the cubed root of m cubed, because I'm allowed to break it up like that. Ultimately, 4m is just the simplified answer. Because what ends up happening, if I could zoom in a little bit more right there, is this cube and cube root cancel on both terms, which is really nice, that the fact that they cancel. I'll take a look at the quizzes, see what choices they gave you. Oh, nice. See what people chose. Most people chose 4m. And then there was a mixture of 8m and 8m squared and all that other fun stuff. But yeah, like I said, that radical symbol does extend all the way across. It was a little bit of a typo, or not typo, I should say, formatting error. Oh, sweet. This problem. Okay, let me write this one down and you'll see exactly what it is. This is number 4. That is the cubed root of 297, w to the 6th, g to the 6th. Boom. There's that problem right there. There are a ton of different ways of handling this. But the fact of the matter is 297 is such an awkward number. 297 is such an awkward number to deal with. It clearly cannot be divided by 2. Let's try dividing it by 3. So I'm going to go to my calculator. 297 divided by 3. I can go farther. Divided by 3, divided by 3, and I'm stuck with an 11. This number, 297, is divisible by 3 times. But then there's an 11 left over. The way that you can express that here, just going to do one giant cube root right here. I could do 3 cubed times 11. Now, I'm still going to put the w and the g in a moment. But 3 cubed times 11 is indeed 297. It doesn't take that much to figure out the makeup of 297. In fact, you can double check that. Clear that. 3 cubed times, no, go back. Cubed times 11 clearly gives you 297. So just to double check to make sure that I wrote that out correctly. What do I do with the W and the G? Well, you could do a number of things, but here's one way you could handle it. One way you can handle it is by breaking up the W and breaking up the G. There's always more than one way to handle this problem. This is just one way of handling how to get this answer. The way you escape a cube root is by having a perfect cube. So this one will escape. This W, this G, and this G will all escape. And that 11 is out of luck. So since that 11 is out of luck, that 11 has to stay within that radical of a cube root. But a 3 escapes. A W and a W escape, so I can write that as W squared. A G and a G escape, so I can write that as G squared. But then ultimately, that cubed root of 11 is stuck inside that problem. I'm going to take a look at the quiz's choices in a moment just to see which one reflected that answer. Because this one was marked yellow in the difficulty section. Nice. Again, 9 people chose the correct answer, and then there was just a small mixture of people who picked the other ones. Okay, hold on. I just want to point something out here. This one's wrong because the W and the G have the wrong exponents. This one's wrong because the W and the G have the wrong exponents. Why is this one wrong? Now, I know it's a little difficult to see. So I'm actually going to write that one a little bit larger. I'm going to write that one a little bit larger so you can see it. This one right here, they wrote it as 3. Well, I'll just write it and then we'll talk about it. Why is that one wrong? You know? Yeah. So if there's no little 3 for the radical, what type of root do you assume it is? Yeah, which is clearly wrong. It shouldn't be a square root. It should be a cube root. It's like one of those tiny little things that can mess everybody up. Whatever that little number is, you have to assume that that's the type of root that it is the entire way through the problem. Unless you have reason to change it. But there's no reason to change that from a cube to a square root. Let's see here. Ooh, that's a good one. Let's see what we got here. I like this one, number 5. The cubed root of 135p to the 4th, the way that this thing is broken up. There you go. There's the problem right there. The cubed root, again, another cubed root. But the way that you should handle these problems is you should try to break down the number as far as it can go. 135 doesn't look familiar to me at all. 135 clearly is divisible by 5. Hey, did I teach you guys the division rule for 3? It's kind of like those silly things in math where it's like it's not really that important, but it's kind of like, oh, that can be helpful. Do you know? Okay, how do you know if a number is divisible by 2? If it's even or not. If it ends in a what? An even number. How do you know if a number is divisible by 5? 0 or 5. The way that you tell if a number is divisible by 3 is if you add up the digits 1 plus 3 plus 5. What do you get? 1 plus 3 plus 5? 9. 1 plus 3 plus 5 is 9. Is that divisible by 3? Then this is divisible by 3. That rule works. Across the board, that rule works. It also works for 9. If the sum of the digits is divisible by 9, then the whole thing's divisible by 9. There's also a rule for 4 and 6 and 8. There's no rule for 7. Just strange. There is a rule for 11, though, but I'm not going to get into those details. Maybe one day for funsies. What is this? Anyway, back to this. I got to break up that 135. 135 divisible by 3. I can do it again. I can do it again. I can't do it again. I got 3 times, and I got a 5 once. So this is the third root of 3 cubed times 5 to the first times, now I got to break up that p. Since it's a cube root, I'm going to try and get a perfect cube, which I did. Got myself a perfect cube right there. And then that singular p is left over. This 3 and this p are allowed to escape. The rest of them are stuck. That 3 escaped. That p escaped. But then that remaining 5 and p were left on their own. Sucks to be them. I'll leave that up for a moment. Here, I'll show you real quick the silly rule for 11. Good? Oh, of course. I'm sorry. Maybe I can try to show them both at the same time. There you go. At the top right here, I never actually circled it. There's the answer for 4, and then at the bottom is the answer for 5. This is why I have concrete notes, because I can't imagine if I ever tried to erase something. Here, let me show you something ridiculous. This is kind of fun for me. Hold on. The number, let's see. Let me see if this works. That number right there is divisible by 11. It's divisible by 11. I guarantee it. If you took that number and divided it by 11, let's see. You get 1121 on the dot, no remainder. There's a ridiculous rule for knowing whether or not a number is divisible by 11. Nope. It has nothing to do with that. Because check this out. You ready? Hold on. It's still divisible by 11. Isn't that messed up? The reason is this. If I add the first digit, I get 1. If I subtract the second digit, 1 minus 2 is negative 1. Plus 3, positive 2. Minus 3, negative 1. Plus 1, 0. Minus 2, negative 2. Plus 2, 0. The result is 0. If the number after the result of alternating between adding and subtracting, if the result is divisible by 11, then the original number is divisible by 11. It's really messed up. I know. It really is messed up. Check this out. It's like 3, 3, 3, 1. No. 2. No, not that. Hold on. I can do it like this. Hold on. I'll do it better. 3, 0, 3, 0, 3, 0, 2. Yeah, that'll work. Plus 3, minus 0, plus 3, minus 0, plus 3, minus 0, plus 2. What's it do? It adds up to 11. So you could take that number, 3030302 divided by 11, right on the dot. It works. One of those crazy mathematical things that you never knew existed. Anywho, math is strange and weird and slightly painful, like an onion. All right. Let's see. Number 9 seems to be the last problem that we definitely need to go over. It is marked in yellow. And then I will continue with what I need to do. In terms of the lesson for today, this is number 9. I'll switch the camera over in a moment. 108, D to the 5th, G to the 3rd. There we go, right there. Anyone ever watched the TV show Lost? It's a sad generation. I don't know. The TV show Lost was was the first TV show that had a cinematic mystery storyline that spread throughout seasons. where something that happened in, let's say, seasons 1 and 2, the answer to that mystery wouldn't be answered till maybe seasons 5 and 6. TV shows nowadays kind of do that, but Lost was one of the first ones that actually did that. And one of the mysteries in Lost was a set of numbers that added up to 108. Kinda. It's not the intent of the show. The plane crash was a means to an end of getting those people to the island. The island was the means of the show. Yeah. Did you watch the whole thing? You should. All right. Just saying. The ending's terrible. But anyway, back to this. 108. It's a square root. But 108 is not a perfect square. It's not. Sucks to be 108. So I go to my calculator and I decide to break up the number 108. 54, 27. I can't go any farther. So hold on. Let me write this out. I got a 2 squared. 3 cubed. 3 cubed, d to the 5th, g to the 3rd. Now, I'm clearly going to have to do something else here in a moment, but I wanted to break up that 108 first. Breaking up that 108 first is necessary for simplifying down this radical. The calculator's not going to do it for you, or not going to simplify it for you. You have to do the legwork. Now, the only way to escape a square root is if you are a perfect square. So I got to break up that 3. I got to break up that d. And I got to break up that g. It's a lot of things floating around all at once. Let me move this just a little bit so the people in the stream can see it, because the glare is kind of messed up. A little more. There we go. That's a lot of stuff. But the way you escape a square root is by having a perfect square as an exponent. Those are the terms that escape. The rest of them do not. Ultimately, let's see, a 2 and a 3 will escape. A 2 and a 3 will escape. Multiplied together, that'll get you 6. A d and a d will escape. That will get you a d squared. A g will escape. And then ultimately, what is left over inside of the radical, well, those are the terms that simply did not escape. Moving that up a bit so you can see that. I'm going to check the quizzes in a moment just to confirm what this thing should have looked like. But it's just a matter of what does escape and what doesn't escape. That's what it comes down to. Let me check. I'll flip back to this in a moment. I just want to look at the quizzes. Oh, interesting. So most people either pick the first one or the last one. The first one having the 6 there. The last one, or both of them having the 6 there. The difference being the exponent on the d. Where did the exponent on the d go? Oh, I see exactly how they could have done that too. They could have done that by taking that d to the 5th. It was like the square root of d to the 5th. And they broke it up where it was like d squared and... No, but then there's another d there. I don't know. Regardless, this is what the answer should have been. Flip that camera back. Boop. Oh, there we go. That is what the answer should have been. Excellent. Just for the sake of argument, the numbers on Lost were 4, 8, 15, 16, 23, 42. Those were the numbers from the TV show Lost. They add up to 108. I just thought that was cool. Anyway, the numbers mean something in the nuance of the show. I can't even get into the details of that show right now, even though I really want to. Okay. Here's what I want to do. I want to continue with some of the simplification things that we need to take care of. I want to continue with some practice problems that are going to take us down a deep, deep, deep road. But I want to remind you of something that I need you to write into your notes. It's something that we've written down before, but I want you to write it down again. Here's what it is. We've written that down before. I need you to write it down again. For the simple sake of number one, repetition, but number two, to solidify what the heck it is that we are actually doing. When you take a radical, or when you take a root of some sort, it is nothing more than a fractional exponent. It is a fractional exponent. And you can remember that fractional exponent if you can remember the phrase power over root. If you can remember power over root, then you know what is actually happening to the value of a. It's being raised to the m power, and you're taking an nth root. So for example, and this is something from one of the worksheets that I've given you in the past, 8 to the 5/3 power. Now, there's going to come a time when you have to evaluate junk like this. And a calculator may or may not help you. A calculator may or may not help you with a problem like this. What one does if they have to describe, okay, how do I get the answer? You've had to do this on my assessments before, where you've had to verbally explain how you would do this problem without a calculator. Now, clearly, I can just say, I can just type it into the calculator and get an answer. Yes, that's fantastic, but what if you have to describe it by words? You've had to do that before on my assessments. The way we handle this particular problem is by first converting it into a radical problem, into a problem with that root symbol, and evaluating it piece by piece. So let's do that. First, I would take this problem and I would rewrite it in the following way. Now, something I want to point out. That exponent of 5, technically, you can write that exponent of 5 on the inside or on the outside. It technically can go either way. My suggestion would be to keep it on the outside for problems like this, because it is easier to evaluate the root first and the power second. So for a problem like this, we have to evaluate the third root of 8. Now, we've talked about the third root of 8. You can break down that number 8. 8 is nothing more than 2 times 2 times 2. It's nothing more than 2 times 2 times 2, 2 cubed. Thus, logically, the cubed root of 8 should be 2. I would evaluate it like that. And then from there, I would just have to evaluate 2 to the 5th power, which is 32. I'm going to show you this on the calculator in a moment. But this is how you can potentially evaluate things without a calculator. And when I say without a calculator, I put that in quotes. People in the live stream couldn't see me making the quote symbols, or I'll do it here, the quote symbols. I say without a calculator, but clearly you can use a calculator to take the cube root of 8, and you can use a calculator to take 2 to the 5th power, but this shows a logical progression from one step to the next. If you had to verbally describe to me how to evaluate to get 32, you could be like, okay, 8 to the 5/3 power is actually the 3rd root of 8 raised to the 5th power. The 3rd root of 8 is 2, and 2 to the 5th power is 32. Yeah, that's perfect. That is exactly the logical thinking that I would expect on a problem like this. If I go to my calculator, 8 to the 5/3 power, notice how I just typed that in. It's a little difficult to see possibly on the live stream, but you can see it gives you that 32, which is great. But if I need you to explain, if I need you to do it, quote, I can't see it, quote, without a calculator, this is what I need to see. This. Let's try another one. Let's try. Oh, that's perfect. Okay, let's do this one. Example. Negative 256 to the 3/4 power. Negative 256 to the 3/4 power. I need you to see this first step. The first step on this particular problem is the most important step. Notice how I'm writing this. The question that usually pops into people's minds. Mr. Markey, does it matter where I put that negative? Answer, yes. Absolutely. Does it matter if that negative is on the inside or the outside? Yes. Yes, it does. I'm going to write something alternative over here. Check this out. In orange right there, I just wrote a different problem. A different problem. A completely different problem. Ms. Mark, you just added parentheses. Yes, I know. I added parentheses, which means that this problem that I just wrote in orange that I am going to erase in a few moments, I'm going to erase it. But notice where the negative sign is now. The negative sign is on the inside. I need you to see that difference. Does it make a difference for your final answer? You better believe it does. This answer right here is actually non-real. This answer right here, the one that I'm pointing to in orange, if you even attempted to type it into your calculator, it would give you an error. You can't actually do that and get a real answer because you're trying to take the 4th root of negative. But on this problem, because there are no parentheses, that exponent is only on the 256, not the negative. As a result, I got to take the 4th root of 256. Well, 256, again, you could break this thing down piece by piece. Oh, man, I got to divide it by 2 that many times. I don't feel like doing that. Okay. 256. I wonder if I can find a 4th power that would get me 256. Okay, hold on. 3 to the 4th power. Nope. 4 to the 4th power. Heck yeah. That didn't take me that long. It was a 4th root. I needed to find a 4th power. It means that the 4th root of 256 is 4. Look at that logical progression. Then I still have to cube it, and cubing that will give me 64. You can double check that. Question. What did that negative do the entire time? Yeah, it just hung out. It did nothing. It just stayed outside of the parentheses because it didn't have the exponent on it. It stayed outside here, it stayed outside here, it stayed outside here. Nothing ever touched it. Just kind of hung out for the ride. Sometimes that'll happen. Sometimes that will. Let's take another problem right here. Check this junk out. This is another example from that worksheet. What the heck? Let me zoom in and say it again. What the heck? That is 64 to the 2/3 power over 343 to the 2/3 power. Oh my gosh. Really? Yeah, it is. There are ways of handling this problem. Now, I'm not going to touch the problem just yet. I'm not going to touch the problem just yet because I have a suspicion about that problem. I have a suspicion, and I want to try out a few things in the calculator before I actually attack this problem. So let's see. Calculator. First, check to see if the two numbers without the exponents are divisible by each other. No. Not even in the least. Nope. Doesn't even reduce. Okay? Calculator. Check to see if I can take a cube root. Look where I'm pointing. Cube root of any of these numbers. Because the fraction is 2 over 3, maybe I can take a cube root of either 64 or 343. Cube root of 64. Hey, look at that junk right there. Cube root of 343. Hey, look at that junk right there. Again, I haven't touched the problem. I just want to emphasize this. I have not touched that problem. But what I am doing instead is I'm just investigating what I can potentially do to the individual numbers in this problem. And apparently I can take the cube root of either one of them. So, check this out. First of all, I am allowed to do this. First of all, I am allowed to do that. Because multiplication or division are the only operations on the inside. I am only allowed to do something like that if multiplication or division were on the inside of the problem. Next, I'm going to convert this thing into what they call radical form. I'm going to convert it into what they call radical form. Because I know, based on what I just did with the calculator, that I can take the cube root of those numbers, both top and bottom of the fraction. I didn't know that beforehand, but thanks to the calculator, I was able to figure that junk out. So this should give me the fraction 4/7, but squared. I still have to square it. Hey, I know how to square those numbers. Mr. Markey, am I allowed to just do 16/49? Yes. Yes, you are. You are allowed to do 16/49 because multiplication or division is the only operation on the inside. I want to show you one thing on the calculator and then I'm done, but it has to do with this problem. I want to show you one thing on the calculator, but it has to do with this particular problem. You guys have no idea what the calculator is capable of most times. Now, you guys are obviously in Algebra 2. Do you know the number one question I get from like freshmen coming over from Brackman in regards to this graphing calculator right here? Oh, you can't see it. This calculator right here. The number one question I get, where's the fraction button? That's the number one question I get. And I'm like, it's called the division symbol. They're like, oh, well, how do I do that? Like, you just hit divide in between two numbers. But did you know that your calculator does have a function that can convert decimals into fractions? Some of you know this. If it doesn't work, then the number can't be converted. But check this junk out. I'm going to type in 64 to the 2/3 power divided by 343 to the 2/3 power. And I'm going to get that decimal right there. If I hit math, the first option is frac. It can convert that decimal into a fraction, which you can clearly, hopefully see at this point, is the exact fraction that we just got on paper. But if I need to see the work, if I need to see a progression, this is what I need to see. Ladies and gentlemen, as I said, I will be throwing a quizzes at you at some point early next week for a grade. Until then, if you have any questions, email me. There's the bell. If you did not leave a comment in the chat, please do so. I've gotten all the people who have commented thus far, but I'm going to sign off.